What's going on, everybody? In this video we're going to look at derivatives of polynomials. Now, in the earlier video we took derivatives by using the limit of f of x plus h minus f of x divided by h as h goes to 0. Well, you're not going to take limits like that. Okay, you may have a problem like that on your test, but you're just not going to take limits like that. So now we're starting to get some formulas for taking derivatives. And so let's take a look at them, and then we've got several examples, a couple of application problems to work. So let's look at this. We've got the derivative of c with respect to x. C is a constant, c is a number. And whenever you take the derivative of a number, you get 0 for an answer. And then I'll come to this one last. And then let's look at this one, the derivative of c times u. So what this is saying is that you can pull the c out and then take the derivative of u with respect to x. So it's just, taking the derivative and then multiplying it times c. And this one, the derivative of u plus v is the derivative of u with respect to x plus the derivative of v with respect to x. Now what this one says is that if you have several terms, you can just take the derivative of each term individually. All right, so let's come back up here to this one. So this one says that if you're taking the derivative of x raised to a power. That's the key there. You've got x raised to some number. Okay? And it doesn't have to be x. It can be r raised to a power, or s raised to a power, t raised to a power. Okay, you've got a variable raised to some number. All right? And so when you have that, all you do to take the derivative is the exponent comes down in front, the n. See, n is your exponent. So the exponent comes down in front, and then you subtract 1 from the exponent. And that's it. Yes, it's that easy. Okay? Now, in later videos, well, the video after this one and the one after that one, we're going to learn some other formulas. Product rule, quotient rule, chain rule. Okay, so be sure you watch that, because this is very important for you to understand how to take derivatives. You're going to use this all through calculus. The power rule, product rule, quotient rule, and chain rule. You've got to know them. If you don't, you're not going to pass your calculus class. Okay, it's that simple. So let's go ahead and look at some examples. So we've got y equals -5. So what's the derivative of that? Well, we're taking the derivative of a number. You see that? Of a constant. So y equals what? 0. All right. Let's look at this one. Y equals x to the third. So let's take the derivative. We've got x raised to a power. Okay, x raised to a power. So what happens? Well, and I put y here. That should be y prime. All right, so look what we have here. The 3 comes down, the exponent comes down, and subtract 1. 3 minus 1 is 2. So we get 3x squared. All right. Let's look at this one, y equals x. So what's the derivative of y equals x? Well, before I do that one, let's look at a function with x. So let's just suppose we have y equals, I don't know, say 5x. Let's go through this step by step. Okay? So we've got x raised to the first power, right? So what does this say to do? It says to bring the 1 down. Okay, so 1 times 5 is 5. Subtract 1 from the exponent, that's 0. So you got 5x to the 0. Well, let me ask you this. What is x to the 0? Well, anything raised to the 0 power is what? 1. And so we get y prime equals 5. You see that? Now, you're not going to do all this work for that. I wanted to work it all out and show you all the steps so you can see where that 5's coming from. And basically what you have, if you have y equals, just say any number, some number times x, well, that derivative is just going to be the coefficient of x if it's x to the first power. Okay? So now let's come over here to this number 3. So what's the coefficient of x? Well, the number in front of x is a 1, right? So what's the derivative of 1x? Well, y prime would just be 1. Okay? So like I said, if you have some number times x and you're going to take the derivative, well, it's just the number that's in front of x. That's your derivative. And this is how it works out. Okay? And this right here, you're not going to show all that work. Okay? You're just going to go straight from here to here. All right? All right, so let's look at number 4. So v equals r to the 10th. So v prime is equal to, well, the 10 comes down, subtract 1 from the exponent. So that's 10r to the 9th. All right, so this is pretty easy, isn't it? But don't worry, you will not be disappointed. It gets more difficult, okay? This section here is a pretty easy section. It's just the power rule, just bringing the exponent down and subtracting 1. That's all it is, okay? But you've got to know it. You've got to practice it. Believe me, I've given tests and I've had these on the test before, and they were just left blank. Some students just couldn't do it. You got to practice it. All right, so what about this one? So we've got y prime. Okay, so the 2 comes down. 2 times 3 is 6. Subtract 1 from the exponent, so I get x to the first power. Now don't write the 1. It's understood to be a 1. So you get 6x. All right. All right, so how about this one? Evaluate the derivative of f of x equals x to the 4th minus 6x squared minus 8x minus 9 at the point -215. All right, so all that means is, okay, we've got the function here. We've got 2x to the 4th minus 6x squared minus 8x minus 9. And we want to take the derivative. So f prime of x is, so what's the derivative? This goes back to that formula that says we can just take the derivative of each term individually. So the 4 comes down, 4 times 2 is 8, subtract 1 from the exponent, minus, and then the 2 comes down, so 2 times 6 is 12, subtract 1 from the exponent, so that's to the first power, minus, and then remember we just talked about a number times x to the first, so that's just 8, and then the derivative of the minus 9 is 0. Derivative of a constant is 0. Okay. All right. And now what do they want us to do? They want us to evaluate the derivative at this number here, at this point, -215. Well, notice in my derivative, all I have is x values. And don't worry, later on in the course, you'll get into finding derivatives, and you'll have x and y terms in your derivatives. Okay, but for now we only have x terms, so all I need to do here, all I need is the -2. So if I do f prime of -2, that's 8 times -2 cubed minus minus 12 times negative 2 minus 8. And for that answer, let's see, what do I get there? I get negative 48 as my answer. So that's evaluating the derivative at a point. Okay? So what does that actually give us if we're evaluating the derivative at a point? Well, let's look at some more examples and see if these examples the more examples we work with, if they're going to explain it to us. And basically, what is the derivative? When you take the derivative of something, well, the derivative, it's a rate of change. Okay, the derivative is a rate of change, and I'll talk about that more as we go through this video and we go through the course. All right. So here, find the slope of a tangent line to the curve y equals 4x to the 7th minus x to the 4th at the point 1, 3. Okay, so the directions for this problem, they're different than the directions for this problem up here, right? But guess what? We're going to work it the same way. So what do they mean? They say find the slope of the tangent line to the curve y equals 4x to the 7th minus x to the 4th. Okay, so to find the slope of a tangent line, you take the derivative, okay? Derivative is a rate of change. So we take the derivative of our function here, and then we evaluate the derivative at that point, and that gives us the slope of the tangent line, okay? So let's go ahead and find the slope of the tangent line, and then I'm going to sketch it out and show you what we've got, show you what it looks like. So we do y prime is 28x to the 6th minus 4x cubed. And so the slope of the tangent line, which we'll just call the slope, we'll call it m, that is y prime of 1. Okay? And so that's going to be 28 times 1 to the 6th minus 4 times 1 cubed, which equals 24. So this is the slope of the tangent line at the point 1, 3 of this curve. So let me just draw a picture of it. And no, I would not be able to graph this thing in my head. I pulled up some software, punched it in, got the graph. That's not the important thing right now. Later on, we'll learn how to graph stuff like this. But for right now, let me just kind of sketch this in. So it's going to look something like this. The graph looks something like that, okay? So, and you take the point 1, 3, that's going to be the point like right in there, okay? Just kind of sketching this. It's nothing accurate, but this is about what the graph looks like. And what happens is you have a line that's tangent to the curve at that point. This is your tangent line. And later on in the course, we're going to learn how to find the equation of that line. All right, so that's the tangent line. And what we've done here is we have found that the slope of that line is 24. That's what you're finding, okay? All right, and I'm not going to go into a lot of detail on what's going on and how that's the, about how that's the slope of the tangent line and all that kind of stuff. What you can do is, if you want to see a detailed video on that, then you can go to YouTube Well, I mean, I'm telling you to go to YouTube. Obviously, if you're watching this video, you're on YouTube right now, so that was kind of a stupid thing to say for me. But anyway, if you want to see a video that explains this in more detail to where you can understand what's going on, then go to my YouTube channel and search my YouTube channel for calculus the tangent and velocity problems. And that video there goes into more depth. Okay, goes into more depth on that matter. All right. But this video is just concentrated on taking the derivative. All right. So let's look at this next example. It says for each 4.0 s cycle, the displacement s in centimeters of a piston is given by the equation s equals t cubed minus 6t squared plus 8t, where t is the time in seconds. Find the instantaneous velocity of the piston for t equals 2.6 seconds. Now, the video before this one goes over instantaneous velocity, rate of change, and all that. So you might want to watch the video right before this one. Okay? All right. So we have the displacement function. We've got s is equal to t cubed minus 6t squared plus 8t. Now, this is the displacement function. This tells us the position at a particular time. Well, what's the change in position? Well, the change in position is what? Velocity. Think about driving down the road in a car. What's happening when you're driving down the road in a car? Your position is changing. How fast is your position changing? Well, that's the speed that you're driving, right? And that's velocity, rate of change of your displacement function. And then what's the change in velocity? Think about if you're driving down the road at 50 miles an hour and you speed up or you slow down. If you speed up, that's acceleration, slowing down, deceleration, right? Well, that's change in velocity. So the derivative of your velocity function would be acceleration. All right? And we get more into that as the course goes on also. All right. So find the instantaneous velocity of the piston for t equals 2.6 seconds. So what do we do there? Well, we take the derivative of this and then we evaluate it at 2.6 seconds. So the velocity, so s prime, which is the velocity, is equal to 3t squared. 3 comes down, subtract 1, minus, then the 2 comes down, 12t, and then plus 8. There's your velocity. So what's the instantaneous velocity at t equals 2.6 seconds? Well, that's the velocity evaluated at 2.6. So I get 3 times 2.6 squared minus 12 times 2.6 plus 8. And let's see what that equals. That is negative 2.9, and we're in centimeters, and that's centimeters per second. So there's your instantaneous velocity. All right. So what that tells us is the piston is moving at negative 2.9 centimeters per second, and it's moving in a negative direction when t is equal to 2.6 seconds. All right. All right, so let's look at this. All right, so it says for what values of x is the tangent to the graph of y equals 3x squared minus 6x parallel to the x-axis? Okay. So let's think about this. So it's asking us about the tangent line, right? And it wants to know when is the tangent line parallel to the x-axis. So they're basically asking when is the slope of the tangent line equal to what? 0, right? That's what they're wanting to know. See, if you have an xy coordinate and we have, let's just say we have a tangent line right here. I don't know where it is, but let's just say here's a tangent line. We want to know when is it parallel to the x-axis. Well, the x-axis is horizontal, so that means the tangent line needs to be horizontal. So we want to know, well, if we have a horizontal line, we know the slope of a horizontal line is 0, right? So that's what we want to know. When is the slope of that tangent line 0? So if we have y equals 3x squared minus 6x, well, when is the slope of that tangent line 0? Well, let's go back up here. How did we find the slope of the tangent line? Well, we did what? We took the derivative and then we evaluated the derivative and got the slope. So what they're doing is they're saying, hey, the slope is 0, but for what x values? We need to know, okay, what do we need to plug in for x to get a slope of 0? So that tells us that if we take the derivative of this, which is 6x minus 6, we want to know when is the slope 0. So when is the derivative equal to 0? And so we solve 6x equals 6, x equal 1. So when x is equal to 1, that's when the slope of the tangent line is 0. All right. So I hope that made sense. Okay. All right. And I tell you what, let's just kind of look at the graph here. You know, if you think about it, what does this graph look like? I'm just going to do it real quick, but just think about it. Here's your function. So how do you graph a parabola? You get the vertex, right? Remember, the vertex is minus b over 2a. That's your x coordinate. So I've got minus b, so a negative 6 over 2 times a is equal to what? That's equal to 1. That's 6 over 6 is 1. And then y of 1 is equal to 3 times 1 squared minus 6 times 1, which is negative 3. Okay? So the vertex here is what? It's 1, negative 3. So 1, 1, 2, 3. So there's your vertex, and we know it's a parabola that opens upward, and we know it's going to go through like this. So it's going to be a parabola like this. And at x equal 1, here's your tangent line right here. It's horizontal, right? Isn't that what it said? There's your tangent line going through where, so actually, you know, real quick, y equals negative 3, that's the equation of your tangent line. Isn't the equation of a horizontal line y equals a number? So there's the equation. Well, that's actually the equation of your tangent line. We'll do more, I'll talk more about that in other videos, but just real quick, I just wanted you to see a picture. There's your tangent. That's what it actually looks like. Okay. All right, so let's move down here to the next problem. I think we got 2 more to work. Okay, keep watching the video. Don't turn it off. All right. So for what value or values of x is the slope of a line tangent to the graph of y equals 4x squared plus 3x equal to the slope of a line tangent to the curve of y equals 5 minus 2x squared? So we want to know when are the slopes of those tangent lines equal. So we've got this curve here. We've got y equals 4x squared plus 3x, and we've got y equals 5 minus 2x squared. And so if we graph those two, at what x values are the slopes of their tangent lines the same? Well, how do we find the slope of the tangent line? You take the derivative and evaluate it at an x value, and that gives you the slope of the tangent line. So if we take the derivative, that's 8x plus 3, and this derivative is negative 4x. Okay, so remember, this right here represents the slope of the tangent line. Okay, and all we have to do is just plug in the x value to get the slope of the tangent line. But here's the slope of your tangent line. That's what these functions right here represent. And what do we want to know? We want to know, when are they equal? When are they the same? Well, that's pretty easy, isn't it? We just set them equal to each other and solve for x. So I've got 8x plus 3 equals negative 4x. And so that's going to be 3 equals, was that 12x? No. X equal negative 12x. So I get x equal negative 1/4. So at x equal negative 1/4, that's when the slope of the tangent lines are the same. Okay? And you can verify it. Plug the negative 1/4 in there. Negative 4 times negative 1/4 is 1. And 8 times negative 1/4 is negative 2. Negative 2 plus 3 is 1. Okay? All right. And I believe this is the last problem. It says a cylinder metal container is heated and then allowed to cool. If the radius is always equal to the height, find an expression for the instantaneous rate of change of the volume with respect to the radius r. Okay, so let's draw a picture. So we've got a cylinder here. Okay, and I have a radius r, and we have a height, we'll call that h, and it wants to know, find an expression for the instantaneous rate of change of the volume with respect to the radius. So what do we need here? We need the formula for the volume of a cylinder. So the volume of a cylinder is what? Pi r squared times h, right? The volume of a cylinder. So how do you find the volume? Well, you take a cross section, okay? So if you cut this in half and looked at the end of it, it would be a circle, right? So how would we find the volume? Well, we would take the area of that circle and multiply it times the height, and that gives us the volume. Now, notice what it tells us. It says if the radius is always equal to the height. So the radius is always equal to the height. So that means r is equal to h. So I get volume is pi r squared, and I'm going to replace h with r because they're the same. And it tells us that in the problem. Now, you might be thinking, well, I understand how you can replace h with r, but how come you didn't replace r with h? Well, because it says find an expression for the instantaneous rate of change of the volume v with respect to the radius r. So that's why we're getting everything in terms of r. Now, if it said with respect to the height h, then I would have replaced r with h and had everything in terms of h. But now I have pi r cubed, and so the prime, the 3 comes down, pi r, subtract 1 squared. And there's your expression for what they asked. Find an expression for the instantaneous rate of change of the volume V with respect to the radius r. Okay? All right, so that's all of this video. I mean, you know, in this applied calculus, I explained in another video kind of what it is. It doesn't go into the depth that calculus for engineering students take, that class they take. It doesn't go into that depth. But it's just the videos won't be as long, which that's probably, I'm sure y'all enjoy that, but that's this video, and we'll do product and quotient rule in the next video, chain rule in the video after that. And so it's important, very important, that you get all that stuff. Okay, so I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.